Hello, everyone, and thank you for joining us today for this month's guest webinar series, Testing at Scale, How to Test When You Go Globally with a Fleet of Tests of Thousands of Machines. Today, I have the pleasure to host Adam Furmanek, which I'm hoping I'm pronouncing his name correctly. But before I'm handing over the mic to Adam, which is, I assume, why most of you are here, I'd like to take a moment to say a few words about PractiTest, who's hosting this webinar today. So for those of you who are not familiar with who PractiTest is, I'll start with introducing myself. Apologies. Hi, my name is Noah. I manage the marketing team at PractiTest. So what PractiTest is, in essence, it's an end-to-end enterprise-grade test management platform, which is powered by QA intelligence and AI. And in simple words, we conceive test management as a centralized testing hub, connecting all elements of testing, regardless of the tool that's being executed or the tool, the type, the methodology. The idea is to have one source of truth related to in regards to everything related to quality within the organization. We are a SaaS solution, and we know that security might be a concern for some organizations, so we make sure to adhere to the relevant security standards, ISO 27001 and SOC Type 2. We are an AWS, we're hosted in AWS, both in Europe and in the US separately. And as much as I mentioned about end-to-end test management, about enterprise grade, our platform can be used as a standalone solution, end-to-end, going all the way from requirements and user stories to the core of our platform, which is the testing modules, test library, in order to ensure reusability, and then test sets and runs for organization, report issues, and then find issues and then report them either via reports or dashboards. But, and it is important to mention that in most cases, we know that customers do have already some solutions for requirements and for issues because the integration or the work they do alongside with dev teams and product teams. And in that aspect, we integrate with all the leading tools, issue trackers and bug trackers such as Jira, ADO, ClickUp, and many others. And then there's bidirectional real-time sync to pull those requirements and user stories into our platform. Testing is done on a test management dedicated platform, which is PractiTest, and then results are reported in real time. A subsample of our customers, just so you get a grasp of who we are. Obviously, most of you already on this session know, and I don't need to explain it, but I said anyway, that nowadays any company is a tech company. In essence, even if you're not in the traditional tech industry, you might be healthcare, finance, retail, education. If you have enough software, it needs to be tested, and it needs to be tested properly. And I think that our customer base is a well representation of this element. This is why I like to show that, not also to brag about the names, but not just, also to emphasize this important. And one last thing that I want to mention, part of the things that we do as a company, in addition to selling a great product, is that we do a lot for the community events such as this webinar, but also next month, we're doing a dedicated event called QA Takes the Lead, which is obviously a free online, not obviously, but it is a free online event when we host leaders, professionals from companies all around the globe. So we're starting for APAC and EU time zone, going all the way to North America, in order to have real life lessons about changing the perception of QA and getting them a seat on the table in a way, and being perceived as an important element, an important unit or role within the organization, not just people who perform testing, which is perhaps what some might be doing, but not just the main goal. So I invite you to join us for that event as well. And one last thing, in case you're not familiar, additional activities that we do is that the State of Testing survey that we've been hosting for the last 13 or 14 years, and the online test conf, a free online event that we will be hosting on September. And without further ado, now I'll hand over to Adam, so you'll have enough time to give the session in a timely manner. Thank you, Adam.
Thank you. Thank you for hosting me. Let me just open up all the thingies I need around. Cool. So we can begin. Hello, everyone. As mentioned, my name is Adam Furmanek, and I'll be your host for the next something like 45 minutes. That's the plan for this talk, during which we are going to talk about how to test stuff when really to go on a large scale. What we kind of would like to discuss today is not necessarily the practices in terms of how to write your code or in terms how to organize the files in your solutions or projects, but we are going to go much deeper into understanding why we test stuff, how to do it efficiently, and especially how to do it when, well, we are dealing with really big applications, like when we are thinking about millions of users, or when we are thinking about stuff that is used across the globe and deployed to thousands of machines. That is the idea. Before going on, a couple words about myself. I'm a software engineer with like 15 years of experience working with big tech, working with startups, companies of basically any size. Also a book writer, author of these two books about .NET, about maths, blogger, public speaker. Drop me a line on email, Twitter, whatever you find useful. And that's it. Let's begin. So the idea, the agenda for today is we would like to actually start by discussing, do we even need tests? And if not, then what else would we need? But if yes, then what types of tests we should use, depending on the application, depending on scale, depending on where we work. Then we are going to actually understand that testing is not about like coming and writing your automated tests or whatever. It's about preparing the application for it to be testable from many various diverse angles. So we are going to understand that good testing actually starts way earlier than writing automated tests, but actually it starts around designing the architecture. Finally, we'll quickly go through some ideas how to keep tests maintainable or how to test different domains, different types of applications. We are going to think from various perspectives, but we are going to use practices that are applicable to applications that are running for millions of users and across the globe. So we are not talking, or we are not thinking about small hello world apps that we deploy to one server and that's it. We are talking about practical examples of how to test applications before deploying them on a really large scale. So let's begin. And the very first question is, do we need tests at all? And as it may sound something like we should never consider this because it's obvious that we do need tests, but sometimes it's actually worth asking ourselves whether what tests do we really need, and if we need them, then, well, why and what do they give? So if we claim that yes, we obviously need tests for our code, for our solutions, then we should ask ourselves a couple of questions. If we need tests, but we don't test standard libraries, then what is the reason? If we need tests, then why don't we have 100% code coverage? Why do we drop tests for UI? Why do we mock external components? Why don't we test edge cases, but only happy paths? Why don't we test obvious things like getters, setters? Why don't we test some trivial code or code that glues a couple of layers? The always question is why, and obviously we have many good answers to that. For instance, we don't test standard libraries because we generally assume, well, they have been tested already. But if we go to changelogs or release changes of like compilers, operating systems, any libraries or frameworks we use, we can find really dumb bugs there have been made in those code bases. For instance, .NET was deploying a priority queue for years that wasn't a priority queue at all. A friend of mine found a bug in Java's concurrent dictionary that was like running into race conditions and wasn't providing enough safety. I myself found a couple of bugs in like C++ runtime on Windows or in Windows operating system itself. Obviously, we have those bugs and we find them. So why don't we write tests against standard libraries? Well, the answer is because we assume they have been tested, so we don't want to spend time and money on doing that, right? That makes sense. Similarly, for 100% code coverage or for not testing things like getters, setters, or some dumb and straightforward glue code that basically calls a couple of functions and nothing more. We do not test those things because, well, either they are super easy and we just see they are correct, or it's hard to test them, and the benefits of testing them are quite small, and we do not get much from spending time and money on writing and maintaining all those tests. Similarly, for mocking external components, why don't we run against a production pieces, but we use some mocks, some emulators, some local Docker containers that only imitate some production pieces? That is because otherwise we would be spending way too much time on testing the application that would negatively impact our performance, our velocity. So we have some good reasons not to test everything. So if we are aware that we don't test everything, then the question is, okay, how do I know which parts we should test? And how do I know which things I can safely omit and still go to production? And the reality is, there are a couple more reasons why we do not focus on good testing. According to some surveys run by Standish Group over the years, between 50 to 80% of product functionality is used rarely or never. Obviously, the credibility of those surveys is quite low, and we shouldn't take them as, a golden truth. But still, I guess you all know the pieces of your application, the places in your code base that no one actually uses, right? So we do not keep the same standards when it comes to testing or quality or whatever around those places because nobody uses them. Similarly, we can say that, hey, if we do not use a proper process for maintaining the software, or we don't follow some best practices around how we organize our work, then we know from the history as an empirical observation that it is easy for a project to go over time and money like twofold or even more. So we basically double the cost and the time needed to build a product. So there are good reasons to not test the application. But at the same time, we have some other things that show that, hey, we really should test our applications because otherwise people's lives are at risk. For instance, Mariner 1, that was or maybe Terac 25, that's even better example. At least 6 patients were given massive overdoses of X-ray radiation just because there was a race condition in a software. Similarly, many companies lost their money. For instance, Knight Capital Group, because they did deployment incorrectly and they reused one bit flag for a feature flag, they used it for some other feature, they lost something like $500 million in less than an hour. Similarly, we can imagine a scenario that's already happened, that we are working on a project for years to launch a spacecraft into space, and then we really need to hit the big red demolish button just because we made a tiny mistake. And in this case, it was missing bar when translating some physical equations from when rewriting them from a piece of paper to a computer code. Similar case is for cosmic ray. It might be hard to believe, but actually in Belgium elections, I think around 2001, one of the candidates got more votes by 4,096 than, in reality. And if we are in computer science longer than 5 minutes, we already recognize that 4,096 is a power of 2. So effectively a bit flipped in the software. So this is how cosmic ray can actually affect our applications. So on one hand, we know that there are pieces in our apps that are not used. And we know that some things are not worth the time and money to test them. But at the same time, we have examples of catastrophic issues happening because of one bit flag or tiny race conditions, something that we observed in our applications so many times. So the question is, should we test or should we not? And the answer is, it's all about the costs, as always. The software is not created just for the sake of creating it. The software is created because it provides some actual value to our customers. And if the value that we provide is lower than the cost of testing the software, then obviously it's just not worth it. It's not cost effective. So should we apply principles like in NASA when they implement the same feature 3 times just to make sure that at least 2 out of 3 implementations will provide the correct calculations? Well, probably it's not worth the effort if we are not running a mission critical system that could actually affect humans' lives or could result in destroying a piece of work that a team worked for the last 5 years. So we always need to find this right balance, when to test and how to test. And unfortunately, when it comes to cost, sometimes it's better not to test our applications and go to production in different way rather than testing everything. So we are going to see in the next parts how we actually can make sure that our applications are ready for production without necessarily testing them. But before going to all of that, let's understand what it means to make things testable. So in order to generally make things testable, we need to understand that good testing starts from the way we build software, not from the way we test it, not from the way we write our automated tests, or we write our integration code, or what queries we send to our application to see its behavior. No, good testing starts right when we design our application. So in order to make our testing life easier and more manageable, we need to start with writing a better software and applying better practices. So in order to do that, we are going to address like 3 aspects of dev experience. So 3 aspects of how we build the software, which heavily affects how we can then test the software before going to production. So the very first aspect of developer experience, something that we really need to take care of when writing any software, is we really need to write applications that we can run locally and without access to the internet. I guess many of us have been in projects that we could not run locally at all, that were like depending heavily on some well-curated shared environment that go offline once in a while, and depends on some external things that are impossible to emulate, impossible to run locally. And if they are down, then, well, our application dies as well. And this is something that we need to address in the first place. All the software we run, we need to be able to run it locally. If we can't run the stuff on our local box, then when are we going to run the tests against this software? Obviously, if we can't run it locally, then we won't run the tests when we work on the software. We will run the tests only after we deploy the software to some shared environment, to non-production, to staging, to UAT, to whatever we call it, and we will run the tests back then, right? But if we run the tests after the deployment to still non-production environment, but after the deployment, and we find some issues, then what's the problem? The biggest issue then is that it takes much longer to identify the bugs and to fix them. So we increase the feedback loop length. We make the feedback loop much longer, so we effectively write the software slower and we deliver lower quality. So the idea that we need to start with, no matter what application we are working with, is we need to be able to run things locally. We need to be able to build the software locally on our box, to test it locally, to debug it locally, to attach debugger and whatever else, to profile it, to capture metrics, logs, everything that our application produces. So this is the idea, something that we really need to have in order to write good code and in turn, good tests. How to achieve that? Well, there are so many solutions and most of them are probably obvious to you. So I will just quickly mention them, like Docker containers, virtual machines, Nix environments, LXC containers, emulators for whatever we have, etc., etc. And also something that might be surprising to some developers because it sounds so obvious, and yet many people, especially working in like very in-house built environment, do not even have a full IDE support. So if you see red squiggles in your IDE, if you can't run the application under debugger easily with like one click, then it's the right time to fix those, because without that, we won't even get to writing a good and fast test that would provide a very nice feedback loop. So generally, that's the very first step, be able to run things locally. But the second thing is, we would like to run the tests automatically and against production-like components. So first, if we are on a team and we have like one shared environment and we deploy to it and then test our stuff, our features or whatever, and by doing that, we block someone else on the team from testing their own feature branch, then it's a super big performance impact that we really should fix right away. There is really no point in having one environment and block others on the team. What we should do instead is we should be able to create a new environment on like just in time from scratch whenever we need it for every single feature branch we have. And this new environment can be created using infrastructure as code, can be created using test containers, just scripts using Docker Compose or whatever can be good enough to create such a thing. And we really need that. Why? Because even though when we have the shared environment and we deploy to it and we are kind of unblocked and can do our job, by doing that, we block and we slow down others on our team. So the whole velocity of the team is heavily impacted, and we again deliver software slower and with lower quality. So generally, whatever you do, once you are able to build and test your applications locally, the next thing, which is always like a good idea, and I would even say it's a must for any fast-paced company, is to be able to run your automated test suite automatically against your feature branch, no matter what you do. Obviously, there will be pros and cons of this approach, and we'll get to that, but generally, this is the direction that we should be aiming. And the third aspect of developer experience is something, well, that is obvious when we are dealing with applications and when we maintain something over time. It's automate everything. Because if there is anything that you need to do manually in terms of deployment, in terms of testing, in terms of changing the configuration in your application, whatever requiring manual action, then most likely you'll become too lazy at some point to do it. And this will lead to first troubles because you deploy something incorrectly or you won't make sure that it works properly and it will fail sometime later. But second thing is it lowers the quality of our tests and our procedures. And the good way to do it is not to wait with introducing automated procedures or wait with the deployment until Monday or whatnot. The better we are like becoming better in deploying and running our stuff means doing it more often and doing it faster. And we can't do that manually. We need to do it automatically using CI/CD, using other solutions like infrastructure as code, deploying often, deploying early, hiding things behind feature toggles, etc., etc. And the important part that we need to also consider here is how we can test all those things when we actually go to production. And as it may sound weird, we actually need to test our application also after we deploy to production. So we should have things like testing behind feature toggles or automated test suites that run against the production environment that we deployed automatically. Once we have those things, then we are able to actually move much faster and automate everything end to end. So those are just the, base ideas how we would like to deal with the software and what we would like to do. But apart from tests and apart from the regular things like unit tests, integration tests, like the manual testing we sometimes do, there are many other things we can do to guarantee that our quality, like code quality or solution quality, is very high. So the very first thing is we need to use compilers as much as possible. If we are using languages that are not compiled, languages like Python, JavaScript, TypeScript, etc. Okay, TypeScript might not be the best idea because it has very good compiler, but things that do not provide a very high level static code analysis, then obviously we'll need to spend more time on testing those things manually. Why don't we test getters and setters in languages like Java, like C#, or any other like languages that are compiled? That is because those getters and setters are kind of tested automatically by the compiler that makes sure that we return proper value or that we assign values accordingly, right? But in some other languages, like Python or JavaScript, we don't have such a guarantee. We need to test those things manually or automatically using unit tests, but still, it's a piece of code that we need to write, we need to run it, and we need to maintain it over time. So generally go towards languages that provide higher safety in terms of how they are compiled, in terms of memory management, in terms of detecting race conditions or detecting any problems with concurrency. Languages like Haskell, like Idris, or sometimes approaches like TLA Plus for verifying whether we have race conditions in our application are very good to and are very helpful when, going for higher quality, especially when we want to automate it. Another idea is metrics. Okay, even if we deployed to production and we verified that with unit tests or whatever that our application is right, we still should have metrics because they will show us logical issues that are super hard to catch when we actually go globally. For instance, imagine that you are writing an e-commerce application for anyone around the planet. In many places around the world, you will have enough stock to, basically sell your stuff. That could be like in the US, in Europe, etc. But if you go to smaller countries, like let's say Luxembourg, right? Then people there may be a bug that manifests itself by not showing all the offers that are available in your e-commerce application, and people will just stop buying. And because those things are super hard to catch when you have a proper environment, then you should have metrics that will actually figure these things out for you. So you need to have metrics that will show you the performance of your application divided by the countries or focusing on specific countries. So you can have separate metrics for the US, separate metrics for countries like Luxembourg. And then when providing automated alarming on these metrics, you can notice that, hey, something broke after I deployed to Luxembourg because this metric went down. So even if we do not test thoroughly our application, we can still use metrics to figure out what is wrong, and we can, for instance, automatically roll things back. Yet another thingy is observability. So extracting signals from application like logs, metrics, traces, context for distributed calls, correlation IDs, or whatever. Extracting all those signals and analyzing them as a whole provides us with a holistic understanding of how things, go throughout our software development lifecycle. So for instance, we can find bugs related to performance. Imagine that you deploy an application that interacts with SQL database, and shortly after the deployment, your database goes crazy and you see CPU spike and all the queries are slower, etc., etc. Even though you tested your application with unit tests, you probably didn't verify whether your application uses indexes in the database efficiently. And it is possible that by changing the application, you change the queries that are sent to the database. And now those queries become way slower because they cannot benefit from the indexes configured in the database anymore. How can you check that something like that with unit tests? That is probably very hard, and we generally don't do that because we only focus on whether the code read and wrote correct data or not. So we need to change our approach. We need to verify the usage of the CPU usage of the database, find the slow queries, attribute them to the code we modified, and then we can see that by changing this or that, we actually affected the indexes, etc. So this is yet another piece we should always have in our mature and enterprise-ready application. But last but not least is customers will also tell us when something is wrong. So we need to also build our applications in a way that when there is a problem, then customers can report this problem to us very easily. Just give them a button, hey, there was an error, click this button to submit this error to us. You can provide a comment what happened. And by the way, include this correlation ID in the message, or we include it automatically, so that we know which workflow failed. So this is something we should have in order to have this full feedback loop to close the cycle of getting feedback after the deployment. Now, a couple of ideas how to keep the tests maintainable on the code level. So generally, whenever we mock, we need to understand that we mock things only because it's better and faster to do it this way. We never mock to provide better correctness, and we never mock to provide higher quality. We mock thingies only because without mocking, we would be slow or not cost effective. Imagine a very simple scenario. If you had a database that you could recreate like with all the testing data independently from others, not breaking the flow for anyone on the team, and do all of that in just 1 millisecond, would you ever mock such a database? And the answer is we should not do that. We should not use mocks in such a case, because mocks are here to provide us the ability to test when it is impossible to do so without mocks. We are not mocking, we should not be mocking things just because this is how we do stuff, or just because this is how some TDD London approach tells us. No, we should mock stuff only if it's impossible to test the application otherwise. Generally, always write your code and always test your code with production components in place. And it is also important to understand that when we talk about mocks, many people may have various definitions. For some of us, mocks are only those Mockito-like things that are, you create with your testing library. For others, mock is something better, something bigger. And they, for instance, write their own mocks with, I don't know, by hand or whatever. But generally, for the purpose of this discussion, any component that is not used in production and is used in tests only is a mock. No matter whether it's like Mockito mock, no matter whether it's like S3 emulator that you run locally, or something that only mimics the production component like H2 in-memory database, all those things are mocks, and we should not be using them. We should always use the production pieces if possible, keeping in mind that mocks are for us only to help us write code or test code faster and cheaper, and they won't provide better quality. But now, a couple of ideas how to, if we need to use Mockito-like mocks in our code base, and how should we write a maintainable code? And obviously, testing code is just like any other code, and we should apply the same best practices when writing and maintaining it. So generally, if you ever see a method when you just repeat a long series of Mockito when statements, or the same initialization code that prepares your objects, prepares all your properties, and when writing new unit test, you just copy this code and paste it and adjust accordingly, then stop doing that. There are different ways to do so. First, this code should be extracted and reused. Second, we can generate those objects automatically, for instance, using AutoFixture or similar faker library that can create all the fake data for us. Third, we should name those things. If we ever see a code in the test that is creating like raw objects without explaining their business meaning, then we could do better. So let's see some couple of examples. For instance, when we have some methods like here on the left, you see we have two tests, test 1 and test 2. And the only thing that we see here is that those two methods, they differ only in setting this one field. And what we should do is we should extract this to a common method. So we can extract this and use builder pattern to prepare some object with pre-initialized state with some fields, and then only modify this single field in the specific tests. So this is the very first thingy. Do not duplicate your code, just extract it and use it like coherently between methods, just like we would do with normal production code. But we can actually do even better, right? Instead of having things like status 1 and status 2, we can actually do things like, hey, how about we have a repository of testing objects that would provide us with an object in given status, right? So this is some code that we can now reuse in many tests. But most importantly, we don't need to write this code by hand. We can use libraries like AutoFixture or Faker that will just generate those objects for us behind the scenes. But even more importantly, instead of using things like status 1, We should name those methods, like providing the business context of what this is happening, right? It's not important that the object has status field set to status 1. It's important that this means that this object is ready to launch or whatever. So just name your things accordingly to convey the business meaning and business perspective. Do not generate data automatically. For instance, instead of creating those things like those objects or whatever manually, you can use libraries that typically use annotations or attributes or whatever, and they will just generate the objects for you automatically. So this way, you don't need to maintain this long code for creating big objects with all the properties, etc., etc. So those are some just basic principles that you can follow. Yet another idea, if you have a class with many tests where you specify the operation, the situation, the outcome. So we know this pattern that we name our tests like, given the customer that is ready to launch, when we try launching it, then the customer is launched, right? We can change this pattern, for instance, to use nested classes. If the operation 1 is something we use a lot, then how about just create a nested class where all the tests for operation 1 are gonna be, put in this single class. So in this way, we can avoid repetition, we can make our code more like easier to maintain, more readable, etc. So those are many ways how we can do that. And now we can actually go to the case of, okay, how do we test stuff in those many different domains, depending on what we do? So before understanding how to do it, we need to understand what principles and what tools and what processes we can use to test our code. So for instance, the very first thing we should always have is infrastructure as code. This lets us create environments automatically, create them in a uniform way, no matter whether we are talking about creating them once or creating 100 of them, and generally repeating the process. So infrastructure as code is something we should always have, and or at least we should always consider. But infrastructure as code has its own problems when we are going to testing across the globe and against millions of machines. Generally, with IAC, it might be hard to test things or to automate things like permissions, allow listing, or generally providing some permissions within our other systems. Sometimes we'll need to deal with making these things manually or automate them in some other way. Similarly, if we are talking about generating certificates, registering in DNS servers, or generating all the stuff that talks about low-level security on the networking layer, it may be much harder to automate that. So generally, when you do IAC, when you try to introduce IAC in your code base, keep that in mind that some pieces might be very challenging. Yet another thing is it may be impossible for us to use IAC because of licenses or because of cost, right? It's super easy when we use Postgres database, which is free. But if we are using some Oracle server that costs a lot, then we might not be able to spin up hundreds of those Oracle servers just like that because we wouldn't have enough licenses. Same goes for hardware. Testing with like CPUs is rather easy, but if you need to test something with like GPU-enabled machines, because for instance, you are going machine learning, etc., then your cloud provider may simply tell you, hey, I don't have those GPUs anymore. And in such a case, your IAC may be impossible, like it may not be able to provide you with the thingies. So generally, IAC is always a great idea to have it around, but it's not like a free lunch. It's not something that you can just introduce and that's it. No, you need to deal with many things that will heavily depend on what environment you're in, what software you use, what cloud provider. When it comes to testing ETL applications, right? Generally, ETL applications are super easy to test with unit tests, even if we use things like Spark or other Hadoop-based solutions that are kind of running in clustered environments, etc. Unit tests are quite straightforward, and we can run them anyway. But unfortunately, unit testing is not enough. because most of the issues that we have around ETL are actually around the process succeeding, but not producing the right data. The whole problem with ETLs is that we succeed to execute our pipelines, but months and years later, we realize that we were incorrectly calculating some data. So in order to test ETL applications properly, I recommend having end-to-end tests on actual small production data set. So if you are doing ETL, just take the smallest country you support, like Luxembourg or whatever. You take the data set for that country and you use it in your tests to verify that the process succeeds. And then you can check the stuff whether it really runs correctly, whether it makes it in time given the machine you are using, whether you do not have crazy memory leaks, whether your code can be serialized and marshaled properly, and also whether all the data you transformed, including dates, including decimal separators, including like null values, etc., those are handled properly. And if you take the smallest data set that really appears in production, then it is possible for you to analyze these data sets and, for instance, calculate how many nows there should be in this data set every single day to verify that your process works properly. So unfortunately for ETL, unit testing is not enough, but doing this golden end-to-end tests should be good. Similarly, when we are talking about machine learning, we have similar issues. Like first, testing machine learning is super expensive because it takes time. Depending on what kind of machine learning application you're dealing with, we may be facing things like, okay, this training takes hours to complete and it's heavily randomized, so we actually do not know whether we even obtained a proper result. So there is no point in testing your machine learning solutions like with unit tests most of the times. What we should do instead is, again, take a small piece of data and train your models on that piece of data, and afterwards verify whether the trained model is actually usable. So to verify it with AUL ROC metrics, verify it with actual inference, verify it with historical data, and compare what your production model produced and what your currently tested model produced, so that you can compare those things and actually see whether those models, they really deliver value. There is no point in doing unit tests in this domain because most of the times those unit tests will not catch any issues. When it comes to UI, or hardware testing on anything that actually requires some sort of device, then we all know the problem that those tests are great, but they kind of fail and they are fragile and they fail because of whatever, the new version of Chrome, new version of Android device, or the button moved from the left side of the screen to the right side of the screen, right? So generally, we all been there, done that we implemented those tests and they were completely unmaintainable. So what we should do instead is, first, we need to identify the group of customers or devices or generally the segment of the market that is crucial for us. And we need to make sure that we work in that segment. And then we take our tests and adjust them so that they have plenty of time, plenty of CPU, plenty of memory. They are retried like 5 times automatically if they fail. And generally, we hope they succeed. So if those tests, they should be completely automated, even if they are flaky. So we just retry them automatically and we let them run. So this is for this crucial segment of the market. But now for all the other cases, like low memory situations, less supported devices, or maybe some atypical browsers or other versions or whatever, we generally want to run a different suite of tests for those, and we let it fail. But now what we do is we track whether a test is failing like once on a time, or whether it fails constantly for a prolonged period of time. So it's generally okay if we have 10 tests and one of them fails every day, as long as it's different tests every single day. If there is a test that fails continuously for a couple of days, then we should look into what's the reason, because probably it signals that something actually broke. So generally have two different groups of tests. One group has plenty of resources, and if it fails, then we immediately take a look what's there. And the other group that we really let it run, let it fail if that's the case, but we observe them periodically if they fail for a prolonged period of time. Yet another thingy, which you already mentioned, generally you can never prove that your code works, but you can always verify whether it worked in the past. But we can use tools around strongly typed languages or static code analysis that will help us understand whether our code is like race condition free or whether it works well. So generally use things like IDRIS, like COC, use SAT, use IOP, use other patterns for analyzing, for structuring your code so that it lowers the possibility that you have bugs. That is the idea. When it comes to load tests and comparison tests, generally, if you want to go on a large scale with thousands of machines, then generally you need to be able to load test your applications. Keep in mind that the easiest way is to take the logs from your production system and just apply the same actions against your non-production system. And this is what most of us do. But understand that first, this takes tons of time because load testing can take you like 10, 12 hours easily. This takes lots of money because you need to pay for the infrastructure. Another thing is you need to deal with GDPR and confidentiality because maybe you can't take production data and run it against your non-production environment. But overall, the most important piece is if you ever load test your applications and you do it in production as well, then always be able to stop your load tests immediately. Because if your load tests cause any issue, then obviously you don't want to kill your infrastructure just because you tested it incorrectly. So if you see anything wrong with your load test, you need to have this safety valve that turns them on immediately and avoids any problems from now on. Yet another thing that I already mentioned is load testing stuff may be actually way too late in your pipeline. And if you test things against your database, then it might be just too late. You already deployed to production and things are slow and you wasted lots of time. So what we should do is we also need to analyze our application, what queries it sends to the SQL database, and then analyze whether those queries use proper indexing structures, etc., even before going to production. So we take the query, we project it onto the production database, and then we verify whether we use indexes efficiently. If we don't, then we can fix it right away without deploying, without running load tests, etc. Last but not least, because we are running out of time, so we'll slowly land this conversation, is testing your configuration and testing your backups and everything around that stuff. Generally, even if you do some innocuous change, like refactoring, like whatever, around restructuring the code clarity, you may actually break quite a lot. So what you would like to do instead is analyze the configuration and the interaction patterns with SQL databases, with configuration, with Key Vault, with etc., and analyze how your application obtained the data. So for instance, you can automate generation of the logs of the requests, right? Whenever you make a request in your unit tests, request to like different web server or whatever, just log it separately, indicating that such and such request has been made. What you can do then is you can take those logs that should be formatted in some plant UML format or some markdown format or whatever, and you can commit them to the repository. So you can get something like documentation as code, okay? So now once you commit them to the repository, the next time you come to your application and you change something, you regenerate those logs files and you use Git to compare the files. And now if you generate a different chain of calls, then you will immediately see in your Git diff even before committing the code. So you can see what the difference is and whether it is expected or not. Now, the whole idea around that is generate files that are easily readable for human when reviewing the code changes. So use Plant UML, Markdown, anything like ASCII art to provide visualization. There are tools, there are libraries for doing that. And this way lets you basically verify whether your non-functional requirements are sort of met. So this is what we would like to be doing. There are many other things that we could consider in here, but because we are running out of time, we'll need to call it a day. This slide deck is available online, so I encourage you to take a look at and analyze other stuff. But just to sum up, code and everything around the code is obviously expensive stuff. And we shouldn't be testing stuff just for the sake of testing. We should analyze what we get from testing our application. We should keep in mind that 80% of our app may not be used at all, so it's probably not worth doing that. And we need to understand that it's always like a game of costs and benefits that we get. Remember about 3 types of this developer experience, and remember about automating everything, because the path to become to perfection is by automating stuff and doing it more often, not by avoiding the problems and pretending like they are not there. And that would be it. If there are any questions, I am happy to take them. At the very end of those slide deck, there are some references to blog posts or whatever you may find interesting. And so I encourage you to take a read. And that being said, I'd like to thank you for attending and thank you for listening. If you happen to have any questions, I'm all yours now.
Before before giving people some time to ask questions, Adam, I will add and address that this topic is very much aligned on what we are hearing and seeing from our own customer base about the fact that we don't need to test just for the sake of testing. I think this is exactly the idea behind the event that we are hosting, as I mentioned, about we want to test in order to provide value. And if we're doing something which is not valuable, then it doesn't make a lot of sense. Okay, it's better to go to the beach than test something which doesn't need to be tested, if I'm going to the extreme. And in that aspect, I do want to mention one. I'll use it again for a small marketing activity, that we are soon will be launching the value score feature within PractiTest, which essentially is doing this, scoring any test that's being executed to show the value that it's providing to the actual results of the project. Exactly with that same line of thinking, the fact that we're not testing just for the sake of testing. So just, it was important for me to mention. If we don't have any, I think we don't have any rising questions at the moment. So with that being said, I would like to thank you, Adam, and to thank you for being with us. Those of you who are watching the recording, Adam has shared here his Twitter, so you can follow him. I think that's a good idea anyway, and then try to reach out to him there. And you are invited, of course, to reach out to us, try us, and that will be all for today. Thank you all.
Thank you.